Looking at solo attempt 2, you can see I've already gotten started here, and kind of the toughest thing about this is probably taking your dot plots and getting them moved into this kind of form of data so you can try to turn it into a box plot. So here I've already worked my way to the center by going in and in and in and in and in, and ended up at 15 for my median, and so that'll help me get going finding my lower and upper quartiles. So here I start from 10 and I start from 5. I go in, keep going. It's obviously going to be 5 or 10, and I end up right at 10 here. So there's my lower quartile, or quartile 1. Same deal here, just going on different rows here. So 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5. We end up at 25 together. There's our upper quartile. Now, what I've also already done is I've already made my number lines here. And what I would recommend you do is when you have two pieces of data you're comparing like this, you're going to want to put them on the same kind of line plot. So yeah, this one doesn't need to go all the way up to 60 because its biggest value is only 40. But when I do them both the same, that will help me look and kind of compare their shapes a little easier. So let's go ahead and get Mr. S's, not me, but another Mr. S. Let's get his class made for the amount of time it takes them to get to school. So our minimum, also mark that, it was 5, and our maximum was 60. So already I know I'm going to put a dot here and a dot on 60, and then my box, I'm ready to start making my box. My lower quartile was 10. My upper quartile was 25. So that tells me 10 and 25. Ooh, and I can see the data appears to be skewed left. And then my median was 15. And so I need to mark that with a single line here, and obviously it's halfway between 10 and 20. And we can see this data in Mr. S's class is quite skewed to the left. All right, let's go ahead and try it for Miss J's class now. And again with Miss J, I've got some of the work already done. The median's already found, so I can do the quartiles. Starting on 20 and 6, I go in 1 and 1, in 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6, and what's exactly between 16 and 16? Well, there's nothing, they're the same number, so 16 is between them. This is our lower quartile. Hopefully your data is pretty close to mine. If I made a small mistake or you made a small mistake, we might be off a little bit, but that shouldn't alter the overall look and feel of our graphs. Let's try it for our lower or upper quartile now. So I go in 1, 1, 1, 1, left and right, left then right, left then right, left then right. Oh, and I have to go between 26 and 30 for my upper quartile, and that would be 28. All right, minimum is here. Maximum's 40. This box plot should be pretty easy to make, so let's go ahead and mark this. So we know 40 is our biggest value. We know 6 down here, pretty close, a little more than halfway. It's right there. And it looks like this data already has a little less variability than the one we just worked with, which we kind of knew was coming. We know our lower quartile is 16, so it's a little more than halfway here. So I can make the left edge of my box at 16. And the upper edge of my box is at 28, because that's my upper quartile. Pretty close to 30, but not quite there. Kind of like somewhere in the 29 to 27 range. And there's my smaller box than it was last time. So again, marked this as my lower quartile, my upper quartile. Let's not forget our median of 20 on there. And here we are. So we can already tell this data looks far less variable than the other data. So if we look at this, take a look at these two classes. We can see they're very, very different in terms of what amount of time they can get to school. But let's also think about what we can see here that we maybe wouldn't be able to see in the dot plots, right? In the dot plots, we can see how many of each student there were for each time. And we know the number of values. So the dot plot helps us see each individual response. So for example, if I look at this box plot, I don't know how many students said 10 minutes for their trip to school. I know 50% of the data is within 10 and 25, but I don't know exactly how many. So here though, you can see exactly what's there. Compared to the box plot, the box plot helps us see the overall shape of the data better. Dot plot helps, how about the dot plot helps us to see the overall shape and spread better. It's kind of like you get to zoom out. You know, we don't have to see all the individual parts to be able to tell someone about the data. Both of these tell me it's skewed left, but this one kind of, the box plot does a better job of cutting to the chase, right? Compared to here, this one, it's like, well, is this more variable than that? I don't know. It's kind of hard to tell. But then you look at the box plots and it's like, oh, clearly this one is far more spread out because of this outlier, right, than this one. And it also kind of helps us to better look at the center, right? If we were to move these on top of each other and compare them, this one would be in this range right here. Go 10 to 25, marked at 15. We have a low of 5 and a high of 60. So we can see it. This box plot helps us better compare data too, because I can see, oh, it looks like Mr. S's class here. It takes the students typically less time to get to school based on the box, but they do have an extreme value that kind of affects how things work there. So it does help us to compare things a little easier than other representations might.